Hey, welcome back everybody. So, we're going to finish up this lesson. We're going to be looking at some equations where these aren't on the unit circle, so we're going to have to use the calculator. Okay, so hopefully you have your calculator handy, and let's take a look at the first one. So we have 3 cosecant theta minus 1 equals negative 9, where theta is between 0 and 360, so we're working in degrees. Okay, so first of all, see that cosecant theta? That's what we have to isolate. So we would get rid of any adding, subtracting from this side first. So add 1 to both sides. And we're down to 3 cosecant theta then equals negative 8. Then we want to get rid of the multiplying by 3, so we divide by 3. And we would have negative 8/3. Okay, now we have a reciprocal function, cosecant. We actually want the sine function, so sine theta equals reciprocal to the right-hand side as well, since we changed cosecant to sine. And we're down to negative 3/8. All right, so that is not one that we recognize, a coordinate we recognize for y on the unit circle. So we need to do basically the inverse sine on both sides, and that will get rid of the sine here. Now what we're going to go after though is the reference angle instead of theta by doing the inverse sine of positive 3/8, okay? And then we'll look back and go, hey, we were looking where sine was negative and figure out what quadrants we're in. Okay, so let's bring up our calculators. And we want to go, oh, what mode should we be in? Check your domain, 0 to 360. So we should be in degree mode. And where am I? Oh, I'm in the wrong place. Let's go up and then over. Good grief. Okay. There, I do believe I'm in degree mode now. Okay, and now we're going to go second function sine of 3 divided by 8. Okay, and we should get, we want to the nearest degree, it says in the question. So our reference angle is going to equal, I believe it was 22 degrees. Let me just bring that up again one more time. Yes, 22 degrees. Okay, so now let's draw that. First of all, reference angle 22 would be here, right? 22 degrees. But if you check back here, we were doing where sine, okay, sine, which is y, is negative. Okay, so y is negative down in quadrant 3 and 4. So we want to draw terminal arms with reference angles of 22 in quadrants 3 and 4. So this rotation angle, therefore, would be, so theta would equal 180 degrees plus our reference angle, 22 degrees. So that should give us 202 degrees. And then this rotation angle all the way around would be essentially 360, go all the way around and then back up 22 degrees. So that should be 360 minus 22 degrees, which would put us at 300 and I believe 38 degrees. Hopefully I did that right. Yes. Okay, and there are our two answers for that particular question. We're in degrees, 0 to 360. Okay, that looks good. Let's try the next one. Okay, so we have 2 cos alpha minus 1 equals 5 cos alpha. Well, first of all, these cosines need to be on the same side. And I kind of want to keep it positive, but it doesn't matter too much. Anyways, I would subtract 2 cos alpha to the other side. So now we have negative 1 equals 5 cos alpha minus 2 cos alpha would be 3 cos alpha. And then we're going to divide by 3 to get rid of the multiplying there. So negative 1 over 3 equals cos alpha. Okay, so now we're going to get rid of the cos by doing the inverse cos. And the reference angle would be the inverse cos of the positive 1/3. Okay, let me just show us getting rid of the cosine by doing the inverse cos, okay? So whatever we do to one side, we do to the other side. Okay, so time to bring up the calculator. Okay, and this time, if you check our mode, we're in radian mode this time. So let's change our calculators over. Okay, so I changed it to radian mode, typed in the inverse cos of 1/3, and it looks like in radians we're getting our reference angle to be, lost that, hang on one second, 1.23, and we want it to the nearest hundredth of a radian, so 1.23. Okay, well, let's think about where that would be. Oh, it's a reference angle. Okay, so we are 1.23. All right, is our reference angle. Now let's go back to here. We wanted where cos, which is x, is negative. So x is negative in quadrant 2 and 3. So let's draw our rotation angles in quadrant 2 and 3, okay, which have reference angles each of 1.23. So we want this first angle in quadrant 2. How do we get that? Well, we'd go all the way to pi, and then we'd subtract 1.23. So the first one would be pi minus 1.23. Okay, and we'll figure that out in a second. And the second one would be, in quadrant 3, would be pi all the way to here plus 1.23. Okay. All right, let's get those answers, and then we'll be able to write our two answers. Oh, not theta this time. What is it? It is alpha. So alpha would equal whatever those two answers are. Okay, let's get those. Pause your video. Hey everyone. So from what I suggested there, our answers would have been 1.91 and 4.37. However, doing the are you done yet check, have you answered what was asked for, and we check our domain, what do you notice? Aha! So we're going to actually be, our angle should be between negative 2 pi and 0. So what we're going to have to do for each of these is actually subtract 2 pi from each of these so that we're actually figuring out this angle, which would be basically negative pi plus 1.23, and this angle. But since we've already figured these out, if we just subtract a full rotation, we would have answers that would be within negative 2 pi to 0. So we'll go ahead and do that. 1.91 minus 2 pi is going to be negative 4.37. And 4.37 minus 2 pi is going to be negative 1.91. And there we go. That should be our answer for alpha between negative 2 pi and 0. Good. Let's look at our general solutions, the last two examples here. How do I know these are general solution equations? Look at your domain here. Okay, so our angle is actually an element of the reals, so we have to name it for all. And this time I remember to write degrees and radians. Okay, so we have cotan of x equals negative 1.5. Now, if this is a unit circle question, we'd just go x over y and we'd be off to the unit circle. But it's not really one that we recognize, so this means we need to use the calculator. And do we have a cotan button on the calculator? No, we don't. Okay, we have a tan button. So first thing we need to do is to reciprocal cotan into tan, and therefore do that to the other side as well. And reciprocal negative 1.5 into 1 over negative 1.5. And there we go. Now we can get at the x by doing the inverse tan, and we'll go after the reference angle first. So it would be the reference angle would equal the inverse tan of negative 1 over 1.5. Okay, so let's bring up the calculator. And what mode should we be in on this one? Hang on 1 second. Degree mode, right? Okay, so let's check our mode. Nope, we're in radians. Okay, so over to degree, hit enter. Okay, now we go second function tan of negative 1 divided by, and yes, you could write it as 1 over negative 1.5. That's fine as well. And there we go. Let's see what we get. Oh, right, we were going to do the positive. Second enter to bring up what we just typed in, because I wanted to do the reference angle, so we're going to delete that negative, keep it in quadrant 1, and we would get a reference angle, oops, of 30, let's see, to the nearest degree, that would round up to 34 degrees. So 34 degrees is our reference angle. All right, let's draw where that would be, reference angle 34, but we're looking at where tan is basically negative, right? So tan would be negative, where the signs of x and y are opposite. So that would be in quadrant 2 and in quadrant 4. Now where you draw that terminal arm really doesn't matter all that much, but our reference angle is 34 degrees. So that's the angle between that terminal arm and the x-axis. Okay, so this is a general solution. So we need this first rotation angle, the principal angle we use for that. And we would have then the angle inside the trig function. So x equals, let's see, that would be 180 minus our reference angle 34. So we should have 146, I believe. So it'd be 146 degrees plus, now let's see, we can actually, since this is in a straight line from each other, we could add 180 degrees, multiples of it, and hit both terminal arms, as long as n was an element of the integers. So 180 degrees n is an element of the integers. There we go. That's our general solution for that one. So tan, cotan, the other solution is in a straight line, so we can name it with one solution. We don't have to come up with this other terminal arm in quadrant 4. All right, let's look at the last one here. Secant theta equals that. Again, we've got a reciprocal function, so we're going to change that to cos, and then flip the right-hand side as well. Okay, we've got to get at the theta, so we get rid of the cos by doing the inverse cos of the right-hand side, and we're going to keep the positive so that we can just work with the reference angle. Let me change that to reference angle, sorry about that. Would equal 1.3427. Okay, let's bring up the calculator, and we got to switch back to radian mode again. Lovely. Okay, so mode, bump, radian, and then quit, and then what are we doing here? Inverse cos, second cos of 1 divided by, you're probably way faster than me at this, aren't you? You're already done. I can see it. Okay, there we go, 1 divided by 1.3427, enter. Okay, so our reference angle is turning, why do I always do that? Is turning out to be, let's see, to 2 decimal places or the nearest hundredth, 0.73. There we go. So 0.73 for our reference angle. Let's figure out what quadrant we would be in. Okay, so we are doing the cosine function, which is x, and it's negative. So where is x negative? That's quadrant 2 and 3. So we draw a couple terminal arms in 2 and 3. Our reference angle is going to be 0.73 for each of these. Okay, so now we need to come up with the general solution. Okay, which means this time we have to name it with 2 because these two terminal arms are not in a straight line from each other or the same distance apart if we go all the way around here. Although we could go, no, well, we won't do that. You could go plus or minus whatever this angle is, but we'll just name it simplistically here. So we'll go, let's see, let's get this angle. That would be pi, because we're in radians, minus 0.73. Okay, so if we go pi minus 0.73, we would get 2.41. Okay, so theta is going to be 2.41. Now, to get back to that terminal arm in quadrant 2, we would have to add a full rotation. So we're adding 2 pi n. Okay, now this other angle here, we're not going to go NEI yet. This other angle, the principal angle, would be basically pi plus 0.73. So that would put us at pi plus 0.73 would put us at 3.87. Plus, again, we'd have to add a full rotation to get back to it, where n is an element of the integers, so we're adding full rotations. And there we go. Okay, so just a sampling of the few types of first degree trig equations we could have. Hopefully the assignment goes well, and next time we're going to be looking at second degree trig equations. All right, we'll see you then. Good job, everyone.